Okay guys, welcome to Miss Haywood Helps. Today we're going to be learning about benchmark fractions and how they can help us with adding and subtracting fractions. Just like any other day, we're going to go over our standard and essential question so that we know what we're learning and why we're learning it. Our standard for today is NF2, so we want to be able to solve word problems involving addition and subtraction of fractions, including cases of unlike denominators. We want to use benchmark fractions and number sense of fractions to estimate mentally and assess the reasonableness of answers. This word reasonableness is going to be very important because we're going to want to be able to see if our answers make sense. And then our essential question, so the question that we should be able to answer at the end of today is what strategies can we use for adding and subtracting fractions with different denominators? And again, we're going to use benchmark fractions to help us be able to do that. So for those of you who don't know, benchmark fractions are fractions that can be defined as common fractions that we can measure or judge against when measuring and comparing or ordering fractions. So as you can see on this anchor chart over here, we have our fractions written in number form. We can see them as models. And then we can also see our fractions on the number line, our benchmark fractions. Typically, we compare fractions to 1/4, 1/3, 1/2, 2/3, and 3/4, just so that we can compare our fractions to those numbers. If you're having still a little trouble of understanding what benchmark fractions are, I want you to pause this right now and watch the benchmark fractions video that I've inserted here. Okay guys, as you can see here, we have what the Georgia Department of Ed said that this standard refers to. And when you get a little bit of time later, I want you to read through that. For this presentation, I kind of want to focus on the example problem. So the problem reads, your teacher gave you 1/7 of a bag of candy. She also gave your friend 1/3 of the bag of candy. If you and your friend combine your candy, what fraction of the bag would you have? Estimate your answer and then calculate. How reasonable was your estimate? So once again, we're seeing that word reasonable. I'm going to highlight it so we can remember that we're going to compare our estimate to the actual answer that we get. Here I've placed fraction tiles. So you'll see that we have the third fractions and the sevenths. I've shaded in 1/3 and I've shaded in 1/7. The reason that I did that is to give you guys a visual of how much candy you have. So you have the 1/7 here, and how much candy your friend has, they have the 1/3. Now, we know that we can't add the fractions off the top of our heads because they have different denominators. But if we look at the 1/3 and the 1/7, and we imagine this 1/7, so if we can imagine it right here, if we imagine this 1/7 here shaded in, I'll put a little dot there, we can see that that 1/3 and that 1/7 is almost 1/2 of the entire thirds and 1/2 of the entire sevenths. So our estimate for this would be 1/2. So I'm going to put 1/2 here. So now we're going to go ahead and add our fractions. Remember, like we said, we cannot add them the way that they are because they don't have common denominators. So we're going to do 1/7 and we'll leave some space, and then we have 1/3. We know that we find the least common denominator by finding the lowest common multiple. And so I know that 7 and 3 both go into 21. And how do I do that? I'm going to multiply 3 over 3 here. And I'm going to multiply 7 over 7 here. That is going to give us, 3 over 21 and 7 over 21. And when we combine those, that equals 10 over 21, which, while we cannot split this in half because 21 doesn't split evenly in half, I know that 10 is half of 20 and 21 is very close to 20. And so if I compare my 10 over 21 to 1/2, I can say that my answer is in fact very reasonable. So this practice problem I pulled from Teleschool on the adding and subtracting fractions work that Fulton County has provided. This comes from the first set of workbook pages, and the problem reads, Alina has 1 gallon, a 1 gallon watering can that is full of water. She uses 3/8 gallon to water her roses and 1/3 gallon to water her geraniums. How much water did Alina use to water both the roses and the geraniums? So part A says, does Alina use more than 1/2 gallon or less than 1/2 gallon of water? Well, in order to answer that without doing any work, I want you to look at this problem kind of the same way that we did the last problem. So you can see here that 3/8 is shaded in, and you can see here that 1/3 is shaded in. If you can imagine this 1/3 being shaded in and added up here, right? So it'd be this 1/3. We could see that this is a little over 1/2 gallon. If we don't want to use the visual, we can go in and we can try to add the two fractions. So we have 3/8 and we have 1/3. Again, in my mind, I'm comparing this fraction to a benchmark fraction. So if I compare 3/8 to, let's say, 1/2, 1/2 of eighths would be 4/8, and 3 is very close to 4/8 or 1/2. So in my mind, I'm thinking that she has used more than 1/2 gallon of water if she adds these two together. But let's see. So we want to find a common denominator between 8 and 3. I know that we're trying to find a common denominator, and so I want to think of all of the numbers that 8 and 3 go into and see what is the first number that they both have in common. I know if we do 8, we have 8, 16, 24, and I know 3 does not go into 8, 3 does not go into 16, but it does go into 24. So I'm going to multiply 3 over 8 by 3 over 3, and I'm going to multiply 1/3 by 8 over 8. My new fractions are now going to be 9 over 24 and 8 over 24. Now that I have a new denominator, I can figure out what half of 24 would be, and that would be 12 over 24. So I'm going to compare, when I add my two new fractions, I'm going to compare it to 12 over 24. Well, if I add 9 and 8, that gives me 17 24ths. And I can see when I compare that 17 24ths is definitely more than 12 24ths. So yes, she uses more than 1/2 gallon of water. So I'm just going to put more here. Excuse my handwriting. So it says, how do you know? Here you're going to put, you found a common denominator, you were able to add the fractions and compare it to 1/2, and you see that it is more than 1/2 gallon of water. It says, estimate how much water Alina used. Well, like I said before, when we looked at this fraction, 1/3, and we looked at 3/8, if we were to add these two together, it looks like it's a little bit more than 1/2. So you could put your estimate there. And then it says, write an equation with equivalent fractions to find the amount of water Alina used. And up here we did that, so that's what you could put there. The next problem we're going over, again, comes from Teleschool, add and subtract fractions and word problems, but this is from the second group of workbook pages. So this says Josanne and Andrea are on a long distance bike ride. They decide that they will stop for water if either of their water bottles is less than half full. Josanne's bottle is 2/5 full, Andrea's bottle is 5/6 full. Should they stop? Explain and show your work. So looking at the fractions that we are using here, we have 2/5 and we have 5/6. We are not adding these fractions. We are not subtracting. We're not multiplying or dividing. We are just comparing them to half full. So I'm going to write 1/2 here, but we may have to convert 1/2 so that we can compare our fractions. When I'm trying to see what is half of fifths, I know in my mind 5 doesn't divide into 2 equally, and so I'm going to have to get it to a number that I can split into 2. And since I have 6 here, I may as well go ahead and find equivalent fractions for both of the numbers. So we have 2/5 and we have 5/6. I know that I'm looking for common denominators, and I want to find the lowest number that both of these numbers go into together. I'm going to start off with my bigger numbers. So we have 6, 12, 18, 24, and 30. I know that 5 does not go into 6, it does not go into 12, it does not go into 18, it does not go into 24, but it does go into 30. And so I'm going to multiply 2/5 times 6 over 6, because 5 times 6 is 30. And I'm going to multiply 5/6 times 5 over 5, because 6 times 5 is 30. Our new fractions are now going to be 12/30, and so that's Josanne has 12/30. I'm going to put a J here. And Andrea has 25/30. Now I can compare these fractions to 1/2 to see if either one of them has less than 1/2 a bottle of water. Well, like I said earlier, we may have to convert our 1/2, and so I'm going to see what can I multiply 2 by to get 30. That's going to be 15. So when I multiply 1/2 times 15 over 15, that gives me 15/30. Now I can look at my fractions and I can see Andrea has more than 15/30, so she has more than 1/2 a bottle of water. But Josanne does not. She has less. 12 is less than 15. So 12 being less than 15 means that she has less than 1/2 bottle of water, and so yes, they need to stop. Okay guys, I hope that this video was a little help. I know the benchmark fractions can be very confusing, and the best advice I have for you guys is to continue to practice and to work it out, and to let your teacher know, me, or if you're watching this and you're not in my class, let your teacher know if you're having any difficulties. I have added some resources here: Learn Zillion, Khan Academy, and Math Geek Mama, and all of these resources really help with understanding the prereqs for benchmark fractions, and so if you click on any one of these, it'll give you more practice. Have a great afternoon, guys.